My name is Juan Munoz. I'm in Mr. Holmes's third period calculus honors class, and today we're going to be talking about graphing and analyzing functions, polynomial functions. That's important. So today the function we're going to do is x minus 2 squared times x plus 1 cubed equals 0. So now we have to analyze this function and we have to write all of our criterias, right? So degree, number of solutions, turning points, leading coefficient, and behavior, the y-intercept, domain, range, and zeros, and then a graph to graph it later. So the function is x minus 2 squared times x plus 1 cubed equals 0. So this function has a degree 5 because when you because x minus 2 squared and x plus 1 cubed, that equals 5, so it's a degree of 5. The number of solutions will be 5 solutions. Turning points are going to be at most 4, because a polynomial function of nth degree will have n minus 1 turning points. So yeah. When you multiply this all out, when you factor it all out, the leading coefficient will end up being 1. And since it's an odd degree function, it's gonna rise one side and fall the other side. And since the leading coefficient is positive, it's gonna rise right and fall left. The domain is gonna be all real numbers. So x such that x is a factor of all real numbers, something like that. The range as well, all real numbers. Y such that y is a factor of all real numbers. The zeros are gonna be you set the function equal to 0. So x minus 2 equals 0. So you just add 2 to the other side, and you get the zeros are 2 multiplicity 2 because it's to the second power, and for the other side it's x plus 1 equals 0. So you subtract 1 to the other side and you get x minus 1 multiplicity 3 because it's to the third degree. Yeah, so now I'm gonna graph it, and our y-intercept is 0, 4, and our zeros are 2 and -1. So it's gonna, and the 2, x equals 2, is gonna have a bounce because it's of even multiplicity, and the -1 is gonna be an intersection. So since it's rise right, fall left, it's gonna come from infinity, pass through -1, get to the y-intercept, cross the axis, and we don't know what the max or min is, so it can go a little higher than that. So we're just gonna draw a line going a little higher, then it's gonna go down to 2, and instead of passing through, it's gonna bounce and go back up. So our function is gonna look like that. Wait, like that. And then these are all of the analyzations. So yeah.